In the skin of a diabetic, it smells almost like fingernail polish, which is polish remover, which is actually acetone. You can smell it in a diabetic who is unconscious. In their breath, you can smell it. And it has horrific effects on the cardiovascular system. And I will show them to you in due course. Today's day is teach them the significance of the nervous system and the endocrine system in doing homeostasis, and use the hypothalamus as one example and the pancreas as the other, nervous and endocrine. Now I've got some pictures in here to help you. Here's the sweat example and the hypothalamus example typed up for you in your presentation. And it's time to begin our language of anatomy portion of this class. But I told you that there were how many feedback systems, how many different mechanisms are used? 3. And how many have I given you? 1. I have given you 1. Negative feedback. And I emphasized it because this is the major feedback system for regulating homeostasis. But there are 2 others that regulate the body's internal environment. The second one, number 2, I don't have slides on this. They're very brief. The second one is positive feedback. If I define negative feedback as resisting a change, positive feedback is amplifying a change. So something happens in my body, to the body's internal environment, and I want that to continue and increase. Now there are lots of examples of this. I'll give you 2. The first one is the process of childbirth. Parturition is a positive feedback system. A hormone produced in the hypothalamus. Surprise you? A hormone made in the hypothalamus is released. The name of that hormone is oxytocin. I won't ask you these. I've got the insulin stuff written down. Just listen for just a minute. Oxytocin then makes its way down to the uterus where the baby's head has turned downward. It binds to the muscle cells, the smooth muscle cells in the wall of the uterus, causing the uterus to squeeze ever so slightly on the child's head in the cervical region, the lower third of the cervix. That initiates a nervous system feedback that ends up back in the brain again. A nervous system pathway from the uterus to the brain. And that feedback to the brain causes the hypothalamus to produce additional oxytocin, depending on the amount of pressure put on the uterus. So the second time the hormone is released, there will be more of it. As the hormone gets to the uterus, it binds to the smooth muscle cells and they contract, but there's more of it this time. And so the muscle cells contract with more force, which then will send a signal to the brain that will be stronger than the second one. Now, if you want to see what this looks like, you have a friend or a sister or a mother who's having a child, go into the room, and they have monitors typically. There's an oscilloscope screen somewhere in the room, and they're monitoring the contractions that are going on. And this hormone's driving it. The really cool thing is when the mom goes in and she's past her due date and they want to get this started. They put a thing in her arm, they put it in the median cubital vein. And they stick it in there and they begin to drip a drug in there. Listen to its name. Pitocin. Oxytocin. It's the medical synthetic version of this hormone to initiate this process. First contraction hits and it dies. Second contraction hits and it dies. Third contraction hits and it dies. And the thing amplifies until it reaches a point where the contractions are basically continuous without relaxation. And hopefully by that time there's been 100% effacement and dilation, and it's time for the baby to be born. So this is a positive feedback, a very important one. Here's the second one that's going to come up in this class. the generation of nerve signals is a positive feedback loop. The generation of nerve signals. Now, I'm just going to probe you a little bit here to see how far you've come already. You already studied A&P, right? You're taking quizzes, you're learning this stuff already? All right? Where is sodium more concentrated? Outside or inside the cell?
Outside.
Outside. Outside the cell. Where's potassium more concentrated? Inside the cell. Why? Why is there more sodium outside than inside? Why is there more potassium inside than outside? Last class period, it was on your quiz. I said, I'm sorry, I didn't tell you about this. There's a protein in the cell membrane. Okay? It's a pump. It's a sodium-potassium pump. Yeah, it's pumping these ions. It's pumping sodium out and potassium in all the time. Now, does sodium in fact move across the cell membrane? Is it able to move across the cell membrane, this sodium? It's not through the phospholipid bilayer, right? But there are proteins in the cell membrane that will allow sodium to go across, right? Specific for sodium. And if you just open up a hole for sodium, which way will sodium go? In. If I just open up a hole for potassium, which way will it go? Out. Why? Do you need energy to do that? Yeah. Simple diffusion, right? It goes from higher to lower concentrations. It's just what it does. Now, this, what we just went through again, is the basis for signaling in all of the muscles and all of the nerves. And the process that gets that started is a positive feedback loop. Now, I know you can't possibly understand all that yet, but you've got the foundation now. And when I get to it in the nervous system, so we got to go through all this interest stuff and all the skin stuff, then we got to do bones and muscles, anatomy, and then I'm going to say this is how a muscle works. And we're going to bring this up again. And I'm going to ask you those same questions. And y'all are going to be ready for that. You're going to say, look at this positive feedback cycle. As it turns out, whenever the signal starts, if you can get it to its threshold, to its critical point, you don't have to do anything else. Because a positive feedback loop will drive that signal all the way through the system. So, if you've got a nerve, for example, and I want to send a signal from my brain to the muscle, all I got to do in the brain is get it started. Once it's started, it will go all the way down that nerve to the muscle. In our nerves and our muscles, it is not a matter of, in getting it started, of how strong the signal is in terms of whether or not you get a signal. You either do or you do not. If you do, the signal goes all the way down and you get whatever effect. Now, the matter of strength of the signal is another matter. So I'll slow that down in the nervous system. We'll talk about that. But I want you to hear it here as a positive feedback mechanism. All right. How many have we done now? 2? Here's the third one. The third one is what I call clock-regulated systems. Clock-regulated systems. So I could go with this from several different directions, and I try different ones every year to try to make my case, to try to convince students how important it is, how important your sleep-wake cycle is, how important your rest and your ability to function in this world is, how dangerous it is to do shift work. I try to do this with kids in a number of different ways. Sometimes I go through and show the statistics in the medical community that we believe are causing deaths in our country every year. This has been documented. Sleep deprivation among medical professionals cause tens of thousands of unnecessary human death in our medical complex in this country every year. I don't see anybody in a room with a scowled face over that. Most people are willing to admit that's true. If your doctor comes in and the doctor has not had any rest for 3 days, the performance level is going to change. If the doctor has worked all night and then has to come into surgery at 6 o'clock the next morning to do surgery, the surgeon is not going to be on their A game. And mistakes get made like this. This also has been demonstrated in the industry. My dad was a chemical engineer for years and years before he retired. And there are a number of chemical industry accidents in refineries and other things that he knows about and have now been documented because huge class action lawsuits have resulted where people have had major mistakes made because of the clock system in their body. All of you know that an individual traveling across multiple time zones will have issues with their health, with their ability to function in the new time zone for several days. All of you know, I'm making some assumptions, all of you know that if you tell yourself on a given night when you go to bed that you have to wake up at 6 tomorrow morning instead of 7, and you have to be somewhere critically important, that you will oftentimes wake up a few moments before your alarm clock goes off. Where is that information coming from? Okay, so there's my blurb to try to convince you an interest. We also know now that essentially every neural and endocrine process in the body is regulated on a daily basis. There are ebbs and flows in all of the hormones and chemistry of your entire body. So now people are beginning to do these clinical things where they're trying to figure out what the impact of the regulation of those daily rhythms are on human health and human abilities. For example, in the field of oncology now, oftentimes individuals with dramatically stage 4 conditions and cancers will be given what's called a circadian profile. They'll work up a clock-related information thing for the treatment because it has now been demonstrated. So with these severe cancers, you want to attack it as hard as you can. But the human body cannot withstand the dosages of chemo, the poison that these people have to take on. And so now we know that there are certain times of day for certain individuals where they can withstand more of this than other times of day. Circadian, circa about day, about a day's cycle, time periods during the day where people are more able to deal with it. I could go on and on with this, but there's no getting around this fact in the world that we live in today. We have biological clocks in our brains. We know where those clocks are. If you had to guess, as a new student of homeostasis, what brain structure has the clock in it, what would you say? What? Hypothalamus. That's where it is. There's a biological clock in your hypothalamus called the suprachiasmatic nucleus. And we know that this structure is playing an important role in regulating the plethora of rhythms that are occurring in my body. And if something happens so that those rhythms are not regulated, it will impact the homeostatic balance of the human body. So I finish this always by saying, young people, pay attention. You're college students, and I know you think you're invincible. There are some of us in the room who are a little older, and I won't point at anyone. Some of us who are a little older than others, and so they will attest to this fact. As you get older, you begin to appreciate the fact that you need rest. So I'm gonna say it this way, and most of you won't listen to me. Why are y'all putting your stuff up? I'm not done. Try to regulate your sleep-wake cycles. Pay attention to the rest you're getting. And see if that won't make a difference in your ability to perform on the field, your ability to perform in the classroom. If there are people in your room and it's 10 o'clock at night, tell them to leave. Blame me. I'm happy with that. You as young people don't think you need it, but the truth is, in the age group between 14 and 19, your body actually needs more rest than mine does. Also documented in sleep study. So I encourage you to do that. You've heard it here today. Homeostasis is regulated by biological clocks. Now let me make an assignment for you. The next few slides